You've seen these lifestyle vloggers all over your feed. They're engaging, their setups look expensive, and they seem perfectly human. But none of these people actually exist. Despite being digital constructs, these synthetic creators are pulling in millions of views and generating significant revenue on platforms like YouTube and Instagram. If you followed AI video for any length of time, this might seem unlikely. We're used to jittery motion, shifting faces, and backgrounds that seem to melt every few seconds. To see how creators are moving past those glitches, we are going to reverse engineer the process by building a continuous, high-quality horror vlog from scratch. Achieving this level of realism isn't the result of a single generate button. It requires a specific multi-layered pipeline where different AI tools handle different parts of the physics and the visuals. Understanding how these systems interact is what allows a creator to move from simply testing out prompts to actually directing a controlled production. The process begins within a generation platform, in this case APOB AI, where the visual assets are managed. The first step is to establish character consistency. We do this by uploading a base image of a face to train what's called a portrait model. This model acts as a mathematical anchor. It ensures that the character's facial features remain identical across every single shot, preventing the morphing effect that usually plagues AI video. Once the character is locked, we need a way to describe complex motion. For this, we use an LLM like Claude to act as the brain for the project. We can't just use standard conversation. We have to feed a technical skill or prompt guide into the LLM so it understands the specific language used by the video generator. This allows the LLM to translate a simple creative idea into the highly specific code needed for realistic lighting, lens types, and physical interactions. By letting an AI brain handle the heavy lifting of physics and lighting math, the creator can focus their energy on the narrative itself. Even with a consistent face, you still have to deal with temporal consistency, keeping the objects in the room and the overall environment identical between scene cuts. One way is a manual loop. You generate a scene, isolate the final frame, and use it as the baseline for the next clip. This forces the AI to build new motion on the old geometry, creating a single consistent world. However, recent updates have introduced storyboard to video, a feature that automates this entire continuity process. Rather than matching frames one by one, you can now feed a single narrative brief into the system to request a multi-minute sequence. The AI then autonomously plans the shoot, selecting camera angles, maintaining the sets, and generating synthetic dialogue to match the story. This shift from manual frame matching to high-level directing represents a major change in how these digital environments are managed. The result of this pipeline is a continuous, atmospheric scene. Here, our synthetic character sits in a dark, rainy apartment, reacting to her window. The physics engine handles complex motion with surprising realism. Look at the lamp in the reflection. It moves with physical weight along a continuous path. What's significant is that this entire environment, the lighting, the rainy window, the character's subtle movements, was synthesized entirely from a text-based workflow. For a sequence like this, the logistics of a traditional shoot, scouting a location, setting up lights, and hiring a crew, are replaced by a series of precise software inputs. As these tools become more accessible, the production value of digital content is becoming less dependent on a creator's budget and more on their technical mastery of the pipeline.